So the good news is, and there's no bad news, I don't think. The good news is that we're actually kind of running ahead a little bit. Last time we talked about, let's see where we are here. We started already diving into Unity UI, classes, functions, scene management. We haven't tackled player preferences yet. I'm going to put that off. Maybe not. Maybe we'll do player preferences as well. So we went through the basics of this game, right? The idea for our game is that, find the right, let's go. There we go. Seems like a lot of stuff on here for our game. So the idea, though, let's read through it and see how scary it sounds. Now that we've seen the basic interface of Unity and the UI and the canvas and what we can do with it. So using UI, text, and sound create a simple adventure game that lets the player explore an immersive world with boundaries in search of a goal. Create a 4-directional pad or a directional pad using 4 UI buttons. We did that north and south, so everyone should be able to extend that east and west. The world needs limits that the user cannot go outside of. We talked about simple rectangles and how to do basic boundary conditions on there. If we exceed the lowest possible x or we exceed the highest possible x, we know that we need to do something like play a sound that is a collision sound, a bump, a thud, or something that sort of thing. And we can also use the mathf clamp function to clamp the user's motion, the player's motion, to keep it within that area. The player will seek or intercept a goal. So the player moves around. We have a position, which is a vector 2. We have an x and a y that we deal with, and we have some goal, which has an x and a y, and we can figure out between the two some vector, which gives us a direction and a magnitude in between the two. Right, so it's an easy way to check how far apart are those two things. Right, so the player needs to minimize their distance somehow between their goal and their current position. They can move using the x and y pads there. And we have to provide some type of feedback. Not necessarily, we want to avoid graphics. The obvious thing of like, oh, there it is, I need to move over there. That's way too obvious. We want to do interesting things like say, oh, you're getting colder, you're getting warmer. And what makes that particularly interesting from a programming point of view is that we're then always saying, okay, compared to the previous state, we have some new state that we changed to. We now have a new distance. We had an old distance, and now we have a new distance. And somehow we have to juggle those two things, the previous state and the new state. Right? A lot of game programming, that's what it's all about. We had some state that the world was in, and now we have some new state that the world is in through the user's actions or through the world's actions, if we had enemies that moved around, that sort of thing. And we have to compare the two and decide what to tell the user about, what to draw on the screen, what to change the text to, and so on and so on. I wonder if I should just, is anyone in class kind of tuned to Discord, well, just in case? Because it'd be much easier for me if I put one in my ear to monitor, then my microphone drops and it gets all crazy. But I'll try it. We'll keep going with it. All right. So we have to work with that. Dynamic feedback should be provided to the user as text and potentially sounds on an ongoing basis. We want to use 3 sounds. Some of them are going to be, say, a one-shot sound where something happens in response to something. Right? The player actually intercepts the goal, stumbles across the key, opens the door, bumps into a monster, that sort of thing. We need a one-shot sound. We need to play in reaction to something, in response to something. And the other sound, we want to have another sound that is basically an indication of sort of proximity. Right? Imagine the classic ping sound, and the ping gets louder, or the heartbeat gets louder as we get closer to the monster, sort of thing. Right? Right. So the closer we get to something, the louder a sound gets. We sort of spatialize the sound depending on how the user moves around. Now, it could be, maybe it's more abstract, and we just say, well, there's background music, or there's something, people have done this cliche where they said, oh, okay, you're looking for a portable stereo, right? So you want to try to maximize the sound, so you hear it faintly off in the distance, and you move, and you say, oh, it got louder, okay, keep moving that direction. You don't necessarily hear it through stereo, and there'll be ways to do that, we'll do that in other games, to say, okay, as you really spatialize the sound, as the player moves in the world, can we take advantage of spatialization? We'll do that eventually. But for now, simple, louder, softer as responding to the player's change of state. We want to make the game interesting so that we have some type of thing, managed resource, to kind of make it a non-trivial situation. Things are going to change over the course of time. We have something to decide, by having a flashlight that we turn on, it becomes easy to explore, but we don't have enough charge of our battery and our flashlight to just have it on the whole time, so we have to go back and forth. Or maybe we can have the flashlight around a certain amount of time, but then we can also encounter batteries and we can pick them up. Right? Maybe certain things we don't see unless the flashlight is on. Certain things we see off in the distance when the flashlight is on, but we can't see them until we're right on top of them when the flashlight's on, that sort of thing. So that's sort of the idea for our managed resource. Or we could have a certain amount of life that after a certain amount of moves, you're just exhausted unless you find food or things like that. The continuous sound, the background music, dynamically indicating distance from the goal. I like to do that one. That's a fun response. So you're just checking things and comparing the distances and so on. A sound when the player reaches some goal, applause. If I tried to have a yay sound somewhere in here, except still the sound in the classroom isn't working just right. Sound when the user hits a boundary. This is nice because if you're feeling around in a dark room, it's one thing to tell them that. It's much cooler to have them have a thud or hit their head or something like that. That's always fun. And then have some sort of score, some sort of scoring that is kept and displayed at the end of the game. It might be the number of moves you made or the number of things you collected before you reached the end. Maybe you have random objects in the world as well. And you keep track of that. So all of these things should be doable with what we've seen so far, right? Everybody, show of hands. Seems like nod. Right? Nothing's too crazy out there. So we should be in good shape on that. The interesting part gets, how do you create your narrative? How do you figure out? One of the things is always how to do it without giving it away, without giving the game sort of just away. And what I mean by that, it's like, well, it's easy to make this too easy. That's why I don't like to say, okay, you move around and you just have to match, this hits that sort of thing, because that's way too easy. And instead, hotter or colder comes in handy for this, right? So let's give it a second to open up here. And since we are ahead on things, we might also use today as a bit of studio and check-in time, just to make sure that everybody has shared their project, everybody's here, we can kind of make sure that's there and spend some time. Who knows, maybe get the, if you use your time diligently, you can kind of, potentially finish the whole project today and have the weekend free and clear and not have to worry about that. So occasionally we'll have studio time if we're ahead. So studio time is just in-class lab/work time. Kind of enforced office hour kind of things. So here we had the beginnings of a game. we had our north and south, and as we move north and south, we had this player, invisible player thing over here in the scene that sort of moving around, and we have the score changing. We put a goal, which is the door. So let's, we'll do a warmer, colder kind of thing. And the idea is really just to say, okay, how do we maintain things? How do we keep our state? Probably preaching to the choir. If we have in here the game manager, we have our hello world. Let's spend more time in the scripts today. Now this game is turn-based. So in the normal Unity game, there's typically stuff going on inside of update here, and things are happening in real time, right? Things move around. Physics happens, things fall, things move, things are updated on the screen. So this game, really, nothing should be going on inside of update, first off. So we're going to leave that out. There's no real time. It's turn-based. So time only advances as the player takes turns. A few people have asked me about, like, well, could you have something that's hunting the player or moving around, things like that? And that's cool and good. The question will be, okay, well, when does that thing get to take its turn? And the simplest thing is say, okay, every time the player takes a turn, then the world gets a chance to do something, to take its turn. So nothing, I just realized, I think I left my drink in the back of the room there. That must be mine. I just grab that before I forget it. So everything should occur according to the user taking a movement, right? Or doing something like the north button, the south button. So my check door that I had set up, where I would check to see, okay, did the player get closer to the door? And if so, expend a turn. A better name for it is probably take turn. All right, so we'll make sure that after north button gets called, after south button gets called, take turn gets called. Right now, flashlight gets set on and off, but that's not actually a turn, that's just changing a bit of state. So we'll assume that nothing really happens. When you turn the flashlight on, nothing happens immediately, or does it? That's kind of an interesting question. If you're standing still and you turn your flashlight on, do we want the player to see something to happen immediately? And if so, how do they react to that? Is that a free turn? Is that a free thing? Does that cost them points? I don't know. Does that cost the use of the flashlight? Well, if they see stuff, it probably should. If they move then, should that count as another use of the flashlight? Well, probably should. And so these are the design decisions we have to but we have to actually start making. So let's come back to the taking a turn, comparing it to, right now, everything is fairly stateless in this game. The only state we have is score, which is surprising, because you would think that there's some kind of state. What other state actually is there that isn't obvious from here? Position, right? We've hidden the position state. Actually, it's not in this script. And in past classes, I would actually make people explicitly use that. Maybe we should. We would say, all right, here's the vector 2 player position, right? Normally that's another thing we're keeping track of that's changing as a result. Now, in our case here, we are using something that Unity has for us that allows us to do a little bit of visualization and some stuff in our head and kind of prime the pump for stuff we're going to do later. By instead of explicitly keeping track of a player position, we're using this position that's over there in an object or in a, in the player object that we created. Right? So that's a bonus of the Unity engine as opposed to really having to do it all by hand. So that's another piece of state. What other state is hidden for us? We can use directly if we want. In this one, go back to the interface. We have the flashlight on and off, right? So now the question with that becomes, do we let that state live in the user interface? Or do we embed that into the object? Right? So how many are you familiar with, there's what, model view model, and model control, the controller, right? This is a real world example of that. Or in the Unity version. And the idea is behind these models of user interface and state and so on. The question is, where does the user interface live? How much state is contained in the user interface versus in the back end? It's kind of grew a lot out of a lot of the web programming models where you had things going on inside the browser versus things going on in the back end. What kind of logic where should logic be and where should state be and so on. And we do have to deal with that sort of thing here as well. We could very well say that, all right, the fact that the flashlight is on or off is only contained in that toggle object. Could do that. I've seen examples in texts even where they said, okay, we're keeping track of the score, and the score is actually only exists in text, in a text field on the screen somewhere. To me, that feels kind of odd. That feels like, the kind of thing we don't want to do. It's way too much stuff at the presentation layer. But there'll be decisions.
You want to change it, you have to parse and get what integers are written.
It's in the text case, that definitely is there, and that to me that feels really awkward. Usually score isn't changing so fast that it probably gives too much overhead to it, but it still feels wrong to me. Now this case, it's not so much the object, but getting the result of that. If I have to go down into the code and there's a flashlight object that I then have to find the toggle component and look at the isOn method of that component. It feels odd to me. Or just it's potentially a bunch of extra stuff. Because now you can imagine as if the game was going really at real time, 60 hertz, 144 times a second, the character was running around like crazy, doing all kinds of stuff, updating a lot, and there was still that flashlight toggle going up and down the hierarchy of GameObject.find, get component, get that would get old real quick. So you're going to be having to make decisions to say, all right, during take a turn here, imagine I've got some kind of actions taken if flashlight is on, right? We'll say that's here. I don't know what those actions are just yet. And the question is, if, right, what is that, what's the contents of that if? Is it GameObject, find, flashlight, etc., or is it just flash on? And what I should do then, instead, let's just say that there's a bool here called flash on. So we say, read our take turn. So now if flash is on, we do this kind of thing. Now it's a question of synchronizing those two things. We have to be careful about it. Maybe it's worth it, maybe it's not worth it. We have to figure out, all right, how do we know if the flashlight is on or off? So we would make sure down here, flash on equals value. So now we would be able to change the flashlight on and off value according to the value passed by that toggle. And in our take turn, what should we do as a result of that? Maybe for now we'll just say print flashlight on while walking. So then we also have to say, well, okay, what's the initial state of the flashlight? Should it be set here? Should it be set in the UI? Decisions. This is a good thing to have in your start, right? So let's say if we're working with a team, and we have a team that's working a lot, we have a designer for the game who's working a lot in the user interface, the GUI, the Unity editor, and we want them to be able to decide, is it on, is it off? So we'll let them set it. So we do want here in the start to say flash on equals game object find let's name it something appropriate. So we find the flashlight toggle, get component toggle, and we look at that is on value. So it makes sense at the beginning of our scene, or the beginning once we've pressed play, we use the start event, the start routine to say, okay, let's synchronize ourselves to what's going on the screen. Synchronize ourselves to the world. So now, I'll save that. Come over here. Our initial state, the flashlight is already on. I'm going to hit play. And the flashlight is on while walking. Turn it off. The value is false, and now the flashlight is on, message doesn't happen anymore. Turn it on again, value is true, the message is happening again. So we're synchronized. Yay, that wasn't that hard. However, we're going to make this non-trivial. We had talked about, like, okay, the flashlight is only on for a certain amount of time, or we've run out of batteries, or how do we deal with that sort of thing? So again, more state. So we're designing our game on the fly. We said, all right, the flashlight is on or off, that's good. But then we might say int, we'll call this battery charges, something like that. So say the battery starts off with some number of charges. We don't know what that's going to be. We'll leave that up to the designer. What do we do when we want to leave something up to the designer? We make it public. Or, better yet, we don't make it public, we make it serializable. So introducing serialize field. So what serialized field does, now I save this script, I come over here, and I look at my game manager. You'll see battery charges is at 0. It's not public though, which is the right thing to do. In object-oriented world, we don't want to arbitrarily make things public just for the heck of it, just to make the Unity editor happy. So we use that serialized field. And this is something that is kind of a special thing for the language, right? Sometimes you'll see these square brackets here that are giving us ways to interact with Unity in kind of a special way, above and beyond typical C#. There'll be things like where we add scriptable objects, or we change the menus, or redefine things about the Unity interface. That's right, you can actually do things like allow the Unity editor to make things sliders, or modify how the Unity editor itself works. And a lot of that time that's going to be provided through these sort of special extensions that we'll occasionally come across. This is the first big one, though, serialized field. Prefer to see that over public. If something's public in a comment, you should say why it's public, if it's not obvious. If it's one of the key interfaces to the class, sure, everybody needs to start the engine, and that's the engine. Makes sense that it's public, start the engine. But if there's some kind of field or property, you should also always be thinking, should this be public? Does it really need to be public? Is it really just because I want to expose it to the Unity editor? Make it serialized field if that's the case. All right. So now we should give it some value over here, and this will be the initial value. So we'll say, we can start off with 6 uses of our flashlight. So Unity now, over on this side, if I did want to print out the number of flashlight uses left, I could say that. I would say, well, all right, flashlight is on while walking. Charges left. And stuff that you put in print, I'll just remind you, remember, print is for debugging and design purposes. In the long run, logic user feedback shouldn't be there. This is really just for prototyping. So we had battery charges. And good coding, bad coding. Let's see. I know I want to decrement the number of battery charges every time the user takes a turn and the flashlight is turned on. So it'd be easy for me to say minus battery charges. Right? That would be decrement battery charges. Take 1 from battery charges. This would be a really bad practice because I've changed the code right in what should be just a debug statement. One of the things I should immediately do when it's time to release the game is delete all those print statements, or I shouldn't count on any of them happening. So having meaningful code like that inside what's basically a debug statement, it's a bad idea. So put that up there. So if the flashlight is on and a turn is taken, our battery charges go down now. Oh, battery charges went negative. That's no good. That's terrible. What should happen when battery charges? What should I do?
Instead of going negative, at 0, just not let it on.
Not let it go beyond. Okay. So how should I do that? So should I say if flash on, if battery, whoops. No, is greater than 1. Let's say if it's greater than 0, we're allowed to subtract. Oops. All right. So now we can walk around. Let me decrement. What happened? I must not have saved. That wasn't my, yeah, I didn't save. This will happen to you all the time as well. The nice thing about Visual Studio is when you're programming in C++, generally when you go and debug, you launch something immediately, it will save the current file. But in Unity, it's not that integrated, so we have to remember save. And now let's come back here and do that one more time. So we hit 0, but it still says flashlight on while walking, charges left 0. And annoyingly, this click, that's still on. Oh, I guess technically if the flashlight ran down, the flashlight wouldn't turn itself, the switch wouldn't turn itself off. That's kind of technicality. But it would be nice, imagine it automatically turns itself off the moment the batteries hit 0. So it'd be nice to tell the user, all right, you used up all your batteries, whether or not they could keep track. The minimum thing we should do is say, well, let's turn the flashlight back off again. So how do we do that? Sorry? The flash state, just change that. Which the flash on, right? So all right. And I can always do this, whether or not you like that or not. Let's offend some people's sensibilities. This is valid. Whoops, that too isn't. That's certainly valid. I almost never write code like that. But in C#, that's cool. C++, that's cool. C, that's cool. We can do that. Save it. So we've solved, whoops, well, that's a good thing. What is that attached to Unity button up there? What was that about? It's going to introduce debugging. This is a good thing. So how many of you use the debugger in Visual Studio to do things, to interactively debug a program? Anybody? Once in a while? One of the biggest things you have, a big reason to use Visual Studio in and of itself is that you can interactively debug a program. Right? We have this debug stuff kind of cooked in there, and we can look at the code while it's running, kind of, sort of. So what I just did, there's a button up here called Attach to Unity. And as long as you only have a single Unity project open, it's no problem, it'll know what you're talking about. So it'll attach itself to there, and now everything else will look pretty normal. Life will be pretty normal. I'll press play in the game, everything is normal. I can continue moving north. Charges left hit 0. You'll notice I don't get that message anymore. My next question was going to be, what do we do to keep that, or to turn that off, or to prevent the user from doing this kind of thing? How could we do that? But we're going to get sidetracked in debugging in a second. So let's go back to Visual Studio here. We haven't changed anything. The game is still playing. And we are still, quote unquote, attached to Unity. You should probably see a few interesting buttons up here. This pause button for break, this stop button for stop debugging, and this restart for restarting. We're not going to hit any of those yet, but I'm going to put a breakpoint right? A breakpoint is basically a special instruction that's inserted in the code so that the moment that code is encountered, there's some state that is triggered, right? And we kind of pop up and return control to the interface here. So say I want to see what is actually going on in take turn. So I click over here, I get this red little dot which says here is a breakpoint, right? And the moment that code is encountered when the program is running, this will pop up. So let's go back to there, and I'm going to take a turn. I hit north. Hit north, immediately got there, and you'll also notice north is now kind of grayed out, and nothing else can really even happen over here. And Unity is kind of frozen for the moment. It's kind of stuck in time for a second. So now Visual Studio is in control. So if we have some weird behavior as a result of something, we can put a breakpoint in and say, okay, let's see what's going on in the code. Let's see what's really happening. A few very useful windows or tabs right down here. You'll see autos, locals, watch one down here at the bottom. And we'll just look at auto and local for the most part. That's showing us the autos it's making an attempt to say, oh, these are variables that are within scope and active and look interesting. You might be interested in what's going on with them at the moment. So you'll see is on or flash on is set to false. Score is set to 12. And the game object that we're looking at is the one game manager. Or sorry, no, the script that we're on is the Hello World script on the game manager. So this is the component we're actually in here. And we see within that component, we can further look at all of the variables that are part of it. Its base, the score, the number of battery charges, the flashlight state, player position, and so on. All kind of exposed for us nicely there. There's additional information over here. We can look at the call stack to see, what was called after what. You can see, oh, north button called take turn. That's what called this. This is all Unity stuff happening even before we get called. This is the call stack. This is what code was happening at the moment we broke, the moment we hit that breakpoint. The most recent one here at the top, hello world, take turn, and the exact position in the code we're at, which was called from our north button code, which was called from an invocable call in Unity, which was called by a Unity event, which was called by button press, which was called by, which was called by, which was called by, all the way, turtles all the way down, as they say. So we know where in the code, we know how we got here, we can see what caused us to happen, and so on, which is all great information. But the most useful stuff is really kind of what's going on in the autos window. And now you see our little yellow arrow up here says, this is the line of code. We hit this breakpoint. We stopped here. Nothing has happened yet. Let's step through the code to see what's going on. So remember up here we had our stop. We had our restart. Pause is, break is no longer active because we're broken. We've hit a breakpoint. We're waiting for something to happen. We have the option of saying continue. Let's do that. Continue. Off we go. We're back to Unity. We said, all right, don't worry about it. Wasn't interested. Life is normal again. I can turn that toggle on and off. I can hit south, and everything hung up again. Why? Because we hit that breakpoint again. In take turn, now we notice here's south button calling take turn. So we can see the difference there. We're at this state, we don't want to continue. Now let's look at these 4 buttons over here. Show next statement, step into, step over, and step out of. They're what allow us to kind of walk through the code, walk through each step as it goes on. So depending on if I only want to look at the code that's happening in this routine. I don't want to follow it down any rabbit holes. Like I want to see, okay, does it call if there's more routines in here and I want to go all the way down, I can use step into. If I want to just execute this code and continue on without going any deeper into the code, I would use step over. If I want to let it execute until it comes back out again, I'd use step out of. But for right now, step over is what we'll do. So we're going to step over this code. You'll see score, which was, I don't know what it was now. It went back out. Score is now 14, so that happened. Now I can float my cursor over here and see, okay, flash on is false. So let's see, I can float over some other things. Battery charge is a 0, flash on. So I can kind of wander around and see what's the current state of things, even including the position of this object. Right? So it's really useful finding out what's going on. And I can continue. I'll say, okay, step over that. All right. Flash on was false, so it didn't do all that stuff. It put me down here. And I'm about to look at this. So now let's see. All right, target. What did target wind up being? This is my target vector I just calculated. 0, 0, or 0, negative 8.5. All right. We compare the magnitude of that, which is 8.5. We compare that to 2. That's obviously going to be false. So we step over that. That got skipped. And now I'm at the end of this routine. If I also just do step over, I've gone back up to south button. So I'm going back up the tree. If I say step over again, now, depending on what the code is, it's decided, okay, that was all your code, now we're back up to Unity. We're not going to let you debug Unity necessarily. So it kicked us back up here. We're back in charge again. But the moment we step back into our code, it breaks again. So to continue on, we really want to say continue. And now we can do our stuff. If we click this again, it's going to get there. So at this point, we probably want to go over to here, back to the Visual Studio, get rid of that breakpoint, and now life will just be normal again. Score changing and everything going on. Right? It's really, really useful. One of the main key things that this is useful for, even a lot of times, just to say, did this code actually run? I wrote this routine, I put it here, and I expect it to run as a result of this thing hitting this thing, or did I actually get close? These two objects, did they bump into one another? And it's really useful just to set a breakpoint in there. It's the alternative to setting. You probably debugged by just putting lots of print statements in your code prior to this, probably, right? Say, okay, let me just print out the variable now, print it out now, print it out now. Why isn't that true? Well, I'll print it out again, put another print statement in there. That's just the standard print debugging. This is definitely more industrial strength debugging. So the last thing I want to do here, though, is I wanted to have that state where, all right, you're not allowed to turn the flashlight on if you have no batteries. That would be nice. So that toggle should never happen if that goes down. So now I've got some more choices to make. I could do things like say, well, okay, if flash on changes, what should happen as a result of flash on changing? What in the user interface should change? Yes? The toggle, right? Yeah. So I could look for everywhere flash on changes, which was here and here. Maybe I start to introduce other things where I'm like, oh, okay, flash on changes as if you trip or you encounter an enemy, your reaction is to immediately turn off the flashlight or something like that. So you have other states. Throughout the code, there's all kinds of different places where flash on changes, but we want the user interface to be updated appropriately throughout. So what technique have I used that I probably want to use again so that I change the least amount of code possible, but to make sure that the flashlight toggle is in sync with the flashlight when it changes?
Property.
The property? So use a get and set?
Yeah, it's sort of like the flash on, so that way it sets it.
Yep.
Sets the property on the toggle thing on.
So remember up here how we had whenever the score changed, right? We used the set function of score so that the text component would be changed. We could do something similar. I'm going to leave this up to you. I'll do it what I would say is the brute force way. I could say, well, all right, down here, I'll do it a bad way. You can fix this. Right? So I'd say, okay, here, and you know what? That's even wrong. That's just bad. That's just a bug. Why is that a bug? What did I intend to do, and what did I actually do?
The line that you added isn't in scope of else.
Right. It's just happening no matter what. So what would the end result be? Right. Whether or not the else occurs, it's just going to drop in there and always turn the flashlight off. Right? Which is bad because I haven't run out of batteries necessarily. I don't want to turn it off every turn if it happened to be on. I really want it to be here. So what I really wanted to have happen is for this, right? Which probably would have been avoided if I actually did it, with the get and set and property and kind of doing it appropriately. So, but now, sort of doing the right thing. You will notice, though, one weird thing, not weird thing, or just a thing, is that I'm still attached to Unity over here. So this might be, whether or not this is going to take effect, I think it will. So this is on, let's use up our batteries. Yeah, it did take effect. Be careful sometimes if you're changing things in your C++ code while you're still attached. It's effectively whether or not it can be hot loaded and changed even though you're still in the debug state over here. Often you want to stop debugging, do your coding, and then it reattach later. Safer thing to do, but usually it'll do the right thing in hot reload. So okay. Is everyone feeling inspired? Are they confused over what they're going to do in their game or a particular feature or thing that I have left out? Or does everyone just want to sort of start tackling their project and
I guess I was just wondering, there's going to be a difficult part in the flashlight, right? If you click the toggle flashlight, something visually shows.
some type of text, some kind of information, right? So we might say, over here in take turn, if flash is on, we want to do something. This is there should be something here, right? Not just text. So it should say something like, if And maybe we decide what's the radius that the flashlight can illuminate. It's 3, something like that. We could say, like in general, every time we took a turn, if we said, all right, if we were within 2 meters, this Unity actually sort of, you can kind of think of it in terms of meters. If we're within 2 meters of the door, it printed out pretty close. We could say something up here that if the flashlight is on, and let's do this, let's just say, the moment we take a turn, it's going to be important for us to know what that target is. So we'll say, if the flashlight is on, we'll say, range equals 5. And can people read my mind? It's trying to read my mind, and it's not doing a great job. So in order to kind of make this logic work, I'm going to do it kind of a way here. I'm going to say int, or maybe make it float, range equals 2. So normally I can see the door if I'm within 2. And I'm going to use the fact that the flashlight was on. Maybe now I need to get this one kind of more normal. All right, so we're saying if the flashlight is on and we have battery charges left, the range of sight should be set to 5, otherwise we leave it set to 2. And we use that range. So turning the flashlight on lets us see further. Maybe we tell it what target magnitude. All right, we shouldn't just print it. We should have some text box that we put that in. And maybe if neither of these things happen, if flashlight is on and that doesn't occur, or range, or there's nothing, or target magnitude is just really, really big, you say you don't see anything, right? It might be here, else print nothing can be seen. So now our flashlight extends our range of vision. It doesn't give us a lot of clues. I mean, maybe it should be more specific. Maybe it should be like, oh, okay, if you can see it, should we tell the user, what direction it's in? That might be good, right? How could we figure out things like that? Say we wanted to figure out, is it northwest of us? Or we want to give it, nice thing about games, especially adventure games like this, you want to give like vague responses, slightly vague responses, so you kind of have to figure out what's going on. So one thing you might want to do is say, well, how do I convert, I have this target vector which tells me the relationship of my goal to where I currently am. And it's going to be a set of 2 numbers, an x offset and a y offset. How can I turn that into off to the north, or off to the northeast, or northwest or southeast? I'm going to leave that up, right? You know that if x is positive, where is it? If x is negative, where is it? If y is positive or negative, you have obvious ones. Then you have to sort of decide, are both of them positive, both of them negative? How do you deal with, how do you use this information, this vector, to get some point across, right? And that's the sort of thing you potentially give the user that feedback for. So if the flashlight is on, you say, oh, it's to the northeast, and they can move more appropriately, and then the flashlight goes out again, like, things like that. Any other head scratchers? No? Okay, so what I'm going to do is I'm going to go through, check now to see who's left who I haven't gotten a project from, and I'll put a list up in a second. I'm going to switch the monitors off so I can like wander around in there and not embarrass myself looking at my computer. But one of y'all, everyone can hopefully have Unity installed and start to work on it. Make sure if I have to find you, I'll ask and maybe start to put names and faces together, or names and masks together. Yeah, how's that sound? Right? Okay. So give me a minute and use the time to make progress. All right. So as far as the stream goes, I'm going to stop the Discord stream. Just checking that it's still running for the moment. And we'll, if you have questions, contact me through Discord, but there's no sense in kind of recording this whole thing. All right. Thank you.